I'm Danny Jenkins. I am the CEO of ThreatLocker, and I'm joined here today with Craig Stevenson, who is the Director of ThreatLocker Ops. So Craig, thank you for joining us.
Thank you very much. Glad to be here.
So we want to show some cool stuff today. So for those who don't know, ThreatLocker is an EPP platform, and we focus on a zero trust approach, which means if something isn't needed, don't let it happen. If the program isn't needed to run, don't let it happen. Therefore, it can't do any bad. And we make that process really easy, whether it's application allow listing by only trusting known good software that you need, ring fencing, controlling what apps can do. So you can stop PowerShell eating your lunch, you can stop Office calling on PowerShell, and you can stop other weaponization of tools, or even network controls or configuration controls. We've got various different controls inside ThreatLocker. Today, we're going to focus on two areas of ThreatLocker. And one particular thing is how can we stop brute force attacks? Because brute force attacks essentially the idea that we're going to hit something over and over again, either with an invalid password until we get the right password, and then we're going to get in on that machine. Of course, unfortunately, the most common one we see still today is RDP invalid logins. I think after 20 years of ransomware, or 10 years of ransomware at this point over RDP, we should be closing down RDP. And one of the cool features of ThreatLocker is we can make sure RDP is shut down everywhere and only accessible by your trusted devices. But sometimes you need to open up RDP, hopefully just on your internal network, and hopefully only to trusted subnets. But even on an internal network, if you get a rogue device on that network, it can be used by attackers. They can hit your server over and over and over again and enable RDP. So today we want to show you how you can use ThreatLocker Ops to detect a brute force attack, or even just respond to an individual invalid login and shut down network access, or at least RDP access in this case, with ThreatLocker Control. So just a quick overview of what each of those products are. ThreatLocker Network Control is our host-based firewall. Now it works a little bit different to every other host-based firewall in that it runs on all your endpoints and all your servers. And unlike a normal host-based firewall, which you go in and you have, you configure it on the device, you can configure ThreatLocker Ops centrally for all of your endpoints and all of your servers. So you can say, I'm closing down all inbound network traffic for my laptops, and I'm going to open up inbound network traffic for my servers, but only from the local subnet. I'm going to open up RDP only from my IT manager's IP address. But there's the problem. Your IT manager's IP address changes every single day. And even on the LAN, he gets a new IP address from DHCP. So with ThreatLocker Network Control, you can do something called dynamic ACLs. And you can say, hey, Craig's my IT manager today. Only his laptop can access it. And whatever his laptop IP address is that day, it will update the ACL. But we don't want to do that today. We want to enable RDP for our entire LAN because we're going to be a little bit reckless. And we want to show you what happens when a bad guy tries to log into RDP multiple times. So we're going to use our ThreatLocker Ops to do that, because what ThreatLocker Ops does, it allows you to take telemetry data from all of the ThreatLocker components, see what programs are opening, what files are being accessed, what files are being deleted, what files are being changed, what event logs are happening in Windows, what elevation attempts are happening, take all of that data and automatically respond either to a high number of occurrences or to an individual attempt. So if someone puts an invalid password into RDP, we can do things like enable a network policy to block RDP. Craig, I'm going to turn over to you because I know you've got your machine set up, and I hope it works for you.
I've said my prayers to the live demo gods, so let's keep it rocking and rolling. All right, so let me share my screen and I'll walk through what I have set up here. So I have a test machine called ops_Windows 10 that has RDP open on it. Since I'm using that as my, let's call it, server. And now the next thing I'm going to do is I'm going to go into network control, and I'm going to create a policy which will shut off access to that server. So I've created that policy here, and that soon as that policy gets turned on, the host-based firewall blocks RDP access to that server.
Now, of course, the better way would be to block it to begin with, wouldn't it?
Yes, the better way to do this would be to have a deny all up front, and then an allow, and then trigger turning off the allow policy.
Okay, but let's do it this way, because we want to live dangerously today on our demo.
Yep. So this is the action I want to have happen in response to detecting a bunch of invalid logins. Now I'm going to go into ThreatLocker Ops, which is going to map detecting the invalid logins to the action I want to perform. So I've created this brute force detection. For the purposes of the demo, it's just waiting for one bad login attempt, and then it's going to shut down RDP. But you can configure it to look for some threshold of bad login attempts. You wouldn't do this in production because one bad login attempt is probably not malicious. But if I saw 100 bad login attempts, that might qualify for your organization as a brute force attempt, in which case you can kick off all these other actions.
I want to talk about a customer here quickly, because we had a customer on trial actually about a year ago, and they came into our support desk and they were testing out ThreatLocker's application allow listing, or Zero Trust anti-malware. And they had it in learning mode. So basically they're at a stage where they're learning all of the files that are needed to run on their computer. And they got a message from the EDR at the time that said that they had a rootkit on their machine talking to Russia. And they came into our support and they said, hey, we're trying to find this rootkit because it should be logged in the allow listing audit because it's a program, it's a rootkit. And our support team couldn't find it. So they asked me to step in, and I jumped on with this customer. It was actually an IT manager's computer at a large MSP. And he had the, and then they said, oh no, we've got it. Our EDR says we've got this rootkit. And I was like, there's no executable, no DLLs, no scripts, nothing running on this machine that's talking to Russia. Now, we didn't have network control on at the time, but what we did do was we had the application control. So I asked the customer, why do they think they've got a rootkit? So they showed me the error, and it was very, very ambiguous. And it talked about a remote-based communication to Russia. And I was like, well, that doesn't mean much. I said, do me a favor. Can you open up your Windows event log? And at the time, they had an event source ID of 4625, invalid login from a Russian IP address about 100,000 times over and over again. It wasn't a rootkit. They had RDP open on a level 3 text computer at an MSP. Now, the MSP said to me, it's impossible. We shut down RDP. Our firewall doesn't allow it. But the tech had taken his laptop home, opened up RDP on his home firewall so he could work not from home, but from his friend's house back to his work computer at home. And the Russian did not get on his computer, but what they did, it was one password away from them gaining access to the machine and gaining access to a ConnectWise automated management platform, which would allow them to push ransomware to thousands of people. So in a case like this, the invalid login would happen more than one time. We're only using one occurrence in this case. And hopefully, what's the next stage then?
Sure. So once we detect the invalid login, the first thing it's going to do is it's going to kick off an alert to our health center, so you'll be able to see it. But in addition, it's going to turn on that NAC policy, which denies RDP to our server.
And that NAC policy has a unique ID, which you've entered in there. I know there's a drop-down coming to make that selectable, but essentially there's a GUID. Every policy in ThreatLocker has a GUID. So you said, enable this NAC policy to turn on this GUID. And that policy is the deny RDP. Now, if you're an IT manager or you're an MSP and you think that RDP is shut down around your environment, and I say the word think because it's so easy when you've got hundreds or thousands of endpoints to not know what's going on in different areas of your business. Policy like this that says, okay, if RDP has an invalid login, I'm just going to block it. Are you blocking it just on the WAN, or are you blocking it for all source addresses there, Craig?
I'm blocking it for everything.
Okay, so you're just saying block. So
I'm just blanket kill it.
So if you want to update that policy then, and let's see what happens.
All right. So while you were talking, by the way, I went ahead and launched a couple failed login RDP attempts at this server. So if I come over to the health center, you can see the 2 failed login attempts that I just did.
And what caused them to show in the health center?
So what causes them to show in the health center is this first condition here. So when like ThreatLocker Ops is policy-based detection and automated response. So we detected the bad login, and in response to detecting the bad login, I've had it take 2 actions automatically. Action number 1 is create a health center alert, and you can actually include useful information in the health center alert. So I've included 2, let's call them variables, related to this specific alert in the health center. One of them is the number of occurrences. So when I go over the health center, you'll see there's 2 alerts, and you'll see there's a number inside of occurrences, and you'll see that's been incremented by 1 because I just tried to do it twice and it's detected both occurrences. And then, go ahead. Yeah, and then action number 2 is I'm turning on that policy, which will deny RDP access. And
so just on the conditions here, because you have another option for condition. In this case, we haven't included an occurrence, but if you scroll up to the policy conditions, you could have said, because you may not want a health center alert when you get 1 login, but you could have added a condition for occurrences, couldn't you? Event log occurrence. So you could have said, don't bother hitting this policy unless it happened 500 times in the last hour or something, or maybe that's too much, but 5, 10 times. I feel like if someone puts their password in 10 times, then they probably deserve to be shut out for a little while.
Yeah. But, and so now if I come over to NAC, you can see that and we'll switch to looking at specifically this machine. You can see that it's automatically enabled that policy, which is now blocking RDP access to my server. And I can now go to my server, investigate what's going on, and possibly refine the policy as well. So I can go in and look at logs and say, okay, I'm seeing blocks from I'm seeing all the attacks coming in from a specific IP address. Maybe I'll narrow my criteria for blocking and just block that IP address block so my internal people can get access to things. But there's a lot of options for how to respond.
Now, the theory for this is we could do this with anything. So of course, if you look at traditional Active Directory and you think about invalid logins, auto lock accounts, and it's a big problem because in Active Directory, Microsoft built in a feature so the administrator account doesn't get locked when you put in 1,000 passwords wrong. And the reason they do that is because if an attacker wanted to take out the administrator's access, they could just sit in the office, try and authenticate to Active Directory 1,000 times, and then the admin can't even log in to solve the problem. So the actual first administrator account in Active Directory doesn't auto lock. But in theory, we could do the same thing here with ThreatLocker. It doesn't have to be RDP. We've used RDP, but if we had this on a domain controller, we could shut down physical network access to that domain controller from a host, not from a username, but from a host, if the user is in the network on a bad host and they're hitting the domain controller. And then the admin could go back in and turn that on once they knew that it was clean. Is that a fair statement, or?
Yeah, that's a fair statement. And so while building this example, I actually came up with an idea for a much cooler example that I did not have time to finish building. But instead of just blanket denying RDP, I could have multiple policies here, and I can have my threat ops response turn on multiple policies. So if I were doing this in production, what I would do is start with a deny all. And then I would have policies in here which allow access. And this is something special we can do with NAC. I would have policies in here which only allow RDP access from specific computers in my network. So say there's 3 admins that sit at 3 admin computers. I could have 3 policies in here which say allow access from this admin, allow access from this admin, and allow access from this admin. And then once I've done that, when I detect the bad logins using the threat ops policy, I can have my multiple actions be action number 1, kill RDP for everyone. Action number 2, allow RDP access from admin 1, allow RDP access from admin 2, allow RDP access from admin 3. And that's completely customizable based on whatever your organization decides is best practice in response to a brute force attack.
So we've got a question about, do we have suggestions on alerts that they can set up? So we have something called ThreatLocker Community. Maybe you want to pull that up. And this isn't fully populated yet. So ThreatLocker Community, initially, it was scheduled to go live, and it's very, very close to going live. Right now, we have an internal battle between our quality assurance and our developers. And one of them's got, well, quality assurance always wins because they have the final say. But it was supposed to go live by the 1st of July. They're really, really working on it. But hey, we got a long weekend. So hopefully, if not 1st of July, by the time people get back off from their drinking and boating or whatever people do in July, watching the fireworks. But ThreatLocker Community is essentially a way where we as ThreatLocker can share suggested policies. And there's an example there. This policy, high number of storage rights. There's another example of a ops policy that if there's a number of high storage rights, this policy, if the action type is right and there's more than 100 rights in a 2-hour period, then we increase the threat level. We could also enable a policy. So these are the type of alerts you want to put in your environment, like blocking RDP from a host that is putting invalid RDP logins. Good idea. You made an administrator account. You want to know when one's been created. It shouldn't happen very often. So I feel like getting an alert saying, hey, someone just created an admin on your domain is not a bad thing. It's almost certain you're going to see something like that in a major ransomware attack. PowerShell elevation, network scanning tools, all of these are things we build into our community provided by ThreatLocker. Not only that, within the next quarter, we're going to open up the community to trusted partners. So other companies, vendors, MSPs, security professionals can publish suggested policies into the community too, and you can follow those. And Craig's team is going to be working alongside with the CISO alerts, the minor attack framework, and making sure known attack methods, known IOCs, like identify as a compromise, are inside the community so you can add them automatically. Now, if you're using ThreatLocker's platform and you're using our Zero Trust anti-malware, our application allow listing, our ring fencing, our network controls, and you're configuring them properly, most of these alerts shouldn't even work. And I say that in a good way because the IOC cannot be hit because they can't execute the program in the first place. But the idea of having the alerts is a secondary backup for when you did allow something by mistake, you were in monitor only, you temporarily disable protection, and it tells you what's happening. Craig, do you want any other really cool things that you can think you can use ops or network control for?
Yes. One of the coolest things we're working on a proof of concept with now is you can actually detect whether or not people are running bad versions of software. Because ThreatLocker, one of the things I can trigger on for ThreatLocker Ops is specific file hashes. So we're looking at building out policy. We had one customer come to us and say, hey, I want to know if anyone in my organization is trying to run an old version of X. And so we can build a threat ops policy that looks for someone attempting to execute a specific file hash, which corresponds to that old version. And the cool part was, as a response to looking for that action, I can call a web API. Well, that guy was like, hey, if I set up a web API that will then run scripts on my machines internally, could I wire this all together to automatically patch old things when people try to run them? So that's an experiment we're working on right now to see if we can get that running for that customer.
So somebody has asked the question, can we respond by blocking just the malicious IP? So yes, what we can do is, in this case, we wouldn't be enabling a policy. What we would do is we'd set up a policy to block bad IP addresses. And then we use these things called tags. So in the top right corner there, you have tags, and you can create good tags, bad tags, other types of tags. And you could have a policy to add the IP using the variable to the tag, and then it would automatically block that IP going forward. So using those tags, and I'm going to answer that one there. I'm just going to go through some of these questions. Okay, so the community tab, I'm not sure if it's showing in beta. So it may be showing in beta, it may be hidden from beta right now. Beta and dev are essentially the same thing, only we've some things are disabled in beta that could cause risk until they've been fully QA'd. So you may be able to see the community tab in beta. If you can't, it will be available very shortly. Hopefully in beta, or hopefully in live, but if not in beta within the next week or so. They're still running final tests on that. And now, can this replace a firewall? So there's a good question. So a firewall is essentially, at its most basic level, is saying what ports and what connections can be made in and out of your network. In modern computing, when we think about endpoints, our network is really just public Wi-Fi. When you think about a LAN inside a network, when you've got servers in the cloud, and I say servers in the cloud, your network is public Wi-Fi. When you go into the office, it's no different to you going home. And the use for a traditional edge, really high-end edge firewall when you've got 100 endpoints sitting in your office is becoming less and less important. And this will do all of the things that an edge firewall will do. However, typically when you think about servers, an edge firewall adds like a second level of protection to say, you should run this on your servers and it will work as a firewall. But it's also good to have a perimeter firewall because then the server isn't doing work when someone's hitting it over and over and over again. It's better to deny at the edge. But if you've got a very simple firewall, so if you've got something in AWS with a single server, quite often you could use ThreatLocker's host-based firewall or network control to block all inbound network traffic to that server, except trusted ports and ports that you need using our dynamic IP addresses as well. So the answer is sometimes, but not always. If you've got a data center type environment, if you've got multiple servers, we always recommend you have a perimeter firewall. Of course, you need some kind of firewalling to do NAT anyway, because you can't give every one of your internal users a public IP address. So at very least, you need a basic firewall at your perimeter. But if you do have servers, an advanced firewall gives you that benefit that you're taking the effort off the endpoints and off the servers and you're putting it onto the perimeter. If you're talking about a normal office environment, just a lower end firewall that has basic NAT, blocks all inbound out traffic, and then using network control is a really good way of seeing all inbound and outbound traffic. One of the cool things about network control is you can see all inbound and outbound traffic in your environment in one central place. So if someone makes an RDP session, you can see it. If someone goes out to Google, you can see it. If you're using ThreatLocker and you haven't tried out version 8, test out version 8 now because we've done some cool stuff with host names, so you can really see what people are going to and what they're doing. Craig, is there anything else you want to add?
Yeah, specifically on the firewalling and cool stuff you can do with NAC. Another thing a customer asked us was, he's got multiple servers in here in his environment. So let's say for a minute he's got 2. He has users talking to those servers, but those servers on a specific port need to be able to talk to each other and only each other. So one of the things he was doing is he was defining all of the rules in NAC for his server to server communication. You know, it's like, I've got users coming in, hitting hitting port 80 or port 443, looking at web stuff on one server. I've got users coming in, hitting web stuff on another server, but one of them's running an API that needs to talk to the other one back and forth. And the short version is, if you really want to implement zero trust, he's going in and he wants to go in, default deny everything, and then only turn on the communication channels that the servers need. That way users can't see, for example, the SSH ports on the server or some of the internal server communication stuff.
Well, and that's how in the old days, I say the old days, like 15, 20 years ago, we built DMZs out. Yeah. And if we wanted to host Exchange in our network, they used to be called Exchange front-end servers, and then you have the Exchange back-end servers, and the front-end servers would have port 443 open from the internet into a DMZ, and then would open RPC ports directly only from those into the other ones, but they couldn't see the Active Directory servers or something like that. And the reason we did that was so if this server got compromised because it was facing the internet, it couldn't get out. By using NAC, you can do the same thing on a flat network. You can have 250 devices on a flat network, and you can choose exactly which devices can see which host based on their host name. The other thing I want to bring up is what's coming at the end of Q3. We're coming into Q3 now, is the ThreatLocker report. Now, the ThreatLocker report is really, really cool. And if you are not a ThreatLocker customer and you want to try that out, or if you are a ThreatLocker Trust customer and you want to try it out, there are some requirements for it. So what the ThreatLocker report does is not just tell you what's running in your environment, not just tell you what the software is doing, but highlights important information. And I want to ask you a question, and I don't know if I'm going to try this, but maybe if anyone is paying attention, raise your hand if you think, if a user said to me, request tomorrow, can I run this dark mode extension in the browser? Raise your hand if you would say no. And now the dark mode extension, this is the facts I'm going to give you about it. It's 4.5-star rated in the Google Web Store. And so if you just raise your hand now and say, would you say no to the user if they ask for that dark mode extension? Now we've got a few people that say no. Now I'm going to ask another question. Well, quite a few people actually. So I'm guessing we got some real ThreatLocker followers here who know what they're doing. So I asked the same question live yesterday or the day before in Dublin, and I got 8 so far out of 100. Now I'm going to ask you the same question. If you knew that every web browser extension can see the data on your web pages, including the password you enter, would that change your position on whether you're going to allow that web browser? So definitely got 7, 8, we're up at 14 hands raised now. 16. I'm going to let it stop going up, and then I'm going to pause. I'm going to say one more thing now, because, and I don't know where our customers are dialing in from, so someone from Dimitri is going to get mad at me any moment now. So we definitely got some hand raises there. Now, what if that web browser extension was written in Russia? Would that change your opinion? Now, I noticed we had some hands taken down, so I'm going to see if they go up again now. So we went back down to 13, so we seem to be going up again now. Now, by the way, maybe it shouldn't, maybe it should change your position, but I think the important fact is you know what you're allowing in your environment. So ThreatLocker is no longer just telling you what you're allowing. They're not just saying, hey, you've got a Chrome extension or browser extension. What they're saying is our labs team go off and research all of that software. And they will give you a report saying, hey, okay, you've got 15 Chrome extensions. This is where they're made. This is where they're funded. This is the companies they're funded by, whether they're funded by TikTok or the ByteDance parent company. Our ops team will go and find out where their employees are based, where the developers are based, whether they've got any previous bad press. Have they had vulnerabilities? Have they been caught in the past putting malware on people's machines? And they're going to put that information in front of you, not to say you shouldn't do it, but so you know well. Now, I'll give you an example. We did a few in the last week, and this is open. It's a closed beta, which means you have to request it. If you are an existing customer, pick a customer who's an end organization. If you're an MSP, or if it's your own organization, you've got to have a decent number of endpoints and just request it. And it takes a few weeks. What they'll do is they'll research every piece of software. They'll look at all your internet traffic, and they'll show you where you're going. 2 examples I want to give. And by the way, every one of these reports comes out with something that you didn't know. And I've never issued one of these reports where someone didn't change 5 or 6 applications in their environment. One is we did a government agency that had 200 machines installed as a test out of 15,000, say. At those 200 machines, we're able to find 15 instances of computers talking to Russia from a US government agency in a single day of network traffic. We're able to find 45 instances talking to China. We're able to find remote access tools that were written in Russia and controlled by Russians. We found active connections to Russian, Chinese, and other computers. Now, some of these were benign. They were just, well, I say benign, they were collecting marketing data and sending stuff on, and some of them were not. But the point is, the organization didn't know this was a problem until they got that report. And as an IT manager, it's sometimes hard for you to go to your managers and say, hey, can I spend money? And they say no, because IT is a cost center. But when you get this report and show them that this is the consequence of users behaving badly, you get a lot of power. Now, that was one of them. Another one we did, we actually found live, active, remote access sessions from Russia. Now, there was lots of smaller stuff that you may decide not to change. Like one of them, we had RDP sessions open, and they immediately used ThreatLocker Network Control to block RDP on all of their endpoints at that point. And that was a big enough client. But in addition to that, we're able to find software, coupon clippers, games, key generators, that were known malware. All of this was found in this software report that we issue. So if you do want to get one of these software reports and you want to do a trial of ThreatLocker, contact ThreatLocker, book a demo if you haven't already done a demo, and ask them, say, hey, I want to do a report. You don't even have to secure, just do a demo. Someone's just put one in the chat, sign up for a web demo and say, hey, I want to do a report. You need to deploy your endpoints. You need to let them, you can leave them in monitor mode. That's not a problem. And we'll give you information about your network that you probably didn't know and about the software you're using. And at the end of that information, you can either make a decision to stop using it or ring fence it and make it more secure.
Yeah, I was actually on that call, and that was kind of amazing. The one where we found the one computer that was letting RDP sessions in from all over the world. And we presented that information to the potential customer in the report, and the customer was immediately like, what computer was that? We showed him what computer it was in the report. He went into ThreatLocker, immediately looked up that computer and blocked RDP access into that computer, which was pretty amazing to see in the span of a couple minutes.
If you have looked at ThreatLocker and you just want to do an updated demo of the new products, please click on book a demo as well on there and just ask the person to show you the new products when they jump on the call with you. But thank you very much for your time, everybody. Craig, thank you.